1.7 is called absolute values and inequalities. Just to keep in mind, whenever you do the absolute value, I'm going to do it here, I'm going to do another one. The absolute value of 4 is equal to 4, and the absolute value of a negative 4 is also equal to 4. Notice that two different answers are inside the absolute value, but absolute value means positive. It needs to come out to be positive. So whenever you're doing absolute value, remember you need two equations. You're gonna come up with your two equations, you're gonna solve them, you're gonna graph them, and you're gonna write them in interval notation. So those are the steps. So if there is no inequality, it's just an equal sign, you still need to break it up into two equations. And here's how to come up with your two equations. You rewrite it without the absolute value sign. Doesn't this look like this without the absolute value sign? And then the other one's going to be 3x minus 2. Notice that these are the same, except the only number that changes is the 8 to a negative 8. Just like we changed the 4 to a negative 4. See that, how we changed those two numbers to their opposites? So that's the whole concept of this. Once you have your two equations set up, you just solve for x. You add 2 to both sides. You get 3x equals 10, x equals 10 thirds. The other one you add 2, you get 3x equals a negative 6. Divide both sides by 3. X is equal to a negative 2. Notice that they're equal signs. If they're only equal signs, you cannot shade. You can only put a closed dot. 10 thirds is the same thing as 3 and 1/3. If you wanted to take 10 and divide it by 3, you're going to get a little over 3. So 10 thirds is over on this side, and a negative 2 is on this side. There is no shading because there is no inequality sign. It's just an equal sign. So if you do see an equal sign, just make two closed dots. Okay, now we're doing it again. There's the straight line. I'm going to rewrite it without the absolute value sign. Doesn't it look very similar to the one without the absolute value? Do not change the 3 minus 2t. Make sure you leave it as 3 minus 2t. Do you notice that these two are the same? Now comes the inequality. The 5 changes to a negative 5. I told you that the number on the right changes to its opposite. And the inequality also changes direction. Do you see that? This changes and this changes only. This changes and this changes only. We solve for t by subtracting 3 to both sides. A negative 2t is less than 2. I need to divide both sides by negative 2. Remember, I divided by a negative number. I do have to switch my sign. 2 divided by negative 2 is a negative 1. Do the same thing on this side. I need to subtract 3 because the opposite of a positive 3 is a negative 3. I get a negative 2t is greater than a negative 8. I divide both sides by a negative 2. T is less than, I have to switch my sign because I divided by a negative number. A negative 8 divided by a negative 2 is a positive 4. Now that I solved it, I can graph them. Well, here's 0. Here's about the 4, positive 4. Here's about a negative 1. Notice that there is no line underneath the inequalities. That means that both of these have to be open. Notice that a negative 1 needs to be shaded to the right. Notice that these two are in the same direction, and 4 has to be shaded to the left. My final answer is interval notation. I need a parenthesis because it's an open circle from a negative 1 to a positive 4, and then another parenthesis, which means open circle. I think we got 3 more, and I think we are done. Yep, we have 3 more, and I think we are done. So let's just do another one. When you see the absolute value on the test, you know you need two solutions. The first one is going to be 2x minus 1 is greater than or equal to 5. Notice that it looks identical to the one up there except the absolute value. The 2x minus 1 does not change. I need to put 2x minus 1 over here. But what does change is the less than or equal to and the negative from 5 to a negative 5. I'm going to add 1. I'm going to add 1. And I'm going to get 2x is greater than or equal to 6. Divide by 2. Divide by 2. X is greater than or equal to 3. Do the same thing over here. I need to add 1. I need to add 1. I'm going to get 2x is less than or equal to a negative 4 because a negative 5 plus 1 is a negative 4. Divide both sides by 2. I get x is less than or equal to a negative 2. I'm going to draw my number line. Here's approximately 0. One answer is 3 and the other answer is a negative 2. Notice that there's a line underneath both of them, which means they both need to be closed. A negative 2 has the arrow going in this direction. Compare them, make sure they are going in the same direction, and 3 is going in this direction. My last thing I have to do is state interval notation. It starts at a negative infinity and goes to a negative 2, and I need a bracket there because it's a closed circle. And the other answer is a bracket 3 to infinity, parenthesis. Number 4, I don't know if I gave you one like this, but number 4, notice that there's an absolute value, and then there's a negative number over there. Whenever you do absolute value always ends up being positive. Go back to here, right here. Whenever you take the absolute value, you're supposed to come up with a positive number. Everybody see that? A positive number. They might try to trick you on the ACT. If you see a negative number over here, you don't even have to do the problem. It's a no solution. You cannot take the absolute value of something and get a negative. So that's a no solution. Okay, I like you to do this one on your own like we've done before. I'd like you to shut it off. I'd like you to work this one out on your own and see if you can do the absolute value of 3x plus 1 is greater than or equal to 2. This is supposed to be greater than or equal to 2. So shut it off and then you do it, and then I'm going to finish it and you can check to see if you're doing it right to make sure you know what you're doing for your worksheet. Okay, I broke this up. I know that 1 is 3x plus 1 is greater than or equal to 2 without the absolute value sign. And the other one is 3x plus 1. I leave it as 3. Notice that this does not change. The sign is going to change to less than or equal to, and the number changes to its opposite. I'm going to subtract 1 to both sides. I get 3x is greater than or equal to 2 minus 1 is 1. Divide both sides by 3. I'm going to get x is greater than or equal to 1/3. X is greater than or equal to 1/3. I'm going to subtract 1. I'm going to subtract 1. I'm going to get 3x is less than or equal to a negative 3. I'm going to divide both sides by 3. X is less than or equal to, when I divided by a number, I divided it by a positive number. I do not have to switch my sign. A negative 3 divided by 3 is a negative 1. When I make my number line, I know that 0's in the middle. I know that a positive 1/3 is to the right of 0, and I know a negative 1 is to the left of 0. Does everybody know why I'm coloring them in closed circles? It's closed circles because there's a line underneath the inequality. The 1/3 is shaded to the right and the negative 1 is shaded to the left. I'm comparing my arrows. Look at this arrow and look at this arrow. Are they in the same direction? Then I know I'm doing it right. I know I have 2 answers because I have 2 shaded areas. One answer is a negative infinity to a negative 1 with a bracket, and the other one is 1/3 to infinity. And that's all the notes for 1.7.